Hi, it's Bronwyn from Wrap, and in this video, I'm going to just go through the basics of an equalizer, which is also called EQ, with you. Now, very simply, EQ can be thought of as a level control for frequency, and they use specialized filters that really influence the volume of specified frequencies or even a range of frequencies within the audio spectrum. Now, there are a lot of reasons to use EQ, but probably the most common use of EQ is to adjust or shape the tone and character. Character is also called the timbre of a sound, and you can do this by boosting, which is turning up, or cutting, which is turning down frequencies. And also, we use another word called attenuating, which is also to turn down something, is to attenuate the level. Now, there are a lot of different types of filters that you can get on an EQ, and there's also some very specific terminology that you need to know. So this is what we would call a multi-band parametric EQ, and allows me to choose the frequency that I want to deal with, and then set the range of frequencies either side of the center or the chosen frequency that I want to affect by using the Q. And I can also adjust the amount of boost or cut I want. And there are a lot of different types of filters. For example, I have a low cut, and this is the high cut. Now, the low cut filter is also known as a high pass filter. And you can see that I've set it here at 20 hertz. So if we take it, say, to 60 hertz, you can see that all the frequencies from 60 hertz and below are cut. And you can set how steep that slope is by using your dB per octave selection over here. The higher the number, the steeper the slope. And the thing about the low cut and the high cut filters is that they cut the frequencies from the specified or the center or the chosen frequency. In this instance, everything below 60 hertz is cut, and everything above 60 hertz is allowed to pass through unfiltered. So this is a low cut, or also known as a high pass filter. You can see here the high pass filter is at 20,000 hertz or 20 kilohertz. Let's get it to, say, 15,000 or 15 kilohertz. And again, you can see that everything above 15 kilohertz is cut. And again, you can see the shape of that filter is nice and steep. And then the lower the number, the more gentle that shape. So everything above 15 kilohertz is going to be cut, but everything below 15 kilohertz allows to pass through unfiltered. So this is then a high cut or a low pass filter. They use those two names interchangeably for the same thing. Now, you can use low cut and high cut filters to remove unwanted or problematic low and high frequencies. And the really cool thing is that you can also automate the frequency so that you can create all sorts of really cool sweeping effects. The next one that we've got is a shelf filter, and we've got low and we've got high shelving filters here. And what shelving filters are used to do is to boost or reduce the low end or the high end frequencies without cutting them off completely. And this is really useful for when you want to make pretty broad tonal changes. So we switch on our filter and it's at 75 hertz. If I turn it up, everything from 75 hertz and below is treated equally. They're not cut and there's no gradual slope. So if I boost it, they all get boosted together. If I cut, they all get cut together. And the same thing here for your high shelf. It's at 7,500 hertz. And again, if I just boost it a little bit, you'll see that all the frequencies above 7,000 odd hertz are affected equally, and the same thing will be for when you cut. So there's no cutting off. It's just everything is either boost or cut together, and they're all treated equally. So this is your low cut, this is your high cut, this is your low shelf, and this is your high shelf. Right. Over here, I've got what we call a parametric band with bell filters. And these bell-shaped filters are also known as peak dip filters. The really cool thing about these is that when you switch them in, you choose your center frequency. In this instance, it's 100 hertz, and you can turn it up or down. But now, you saw when I turned it up that there's a bit of yellow that is colored on all the other frequencies as well. Not just 100 hertz is being boosted or 100 hertz being cut. What's happening is that all the frequencies either side of that chosen frequency are being affected depending on the shape of this slope or this filter or this curve over here. So what happens is I can now choose how many of those frequencies either side of the center frequency are affected by using my Q. And the Q is the quality or the resonance of the filter. And you can see that the higher the number, the more I start to really zoom in on that specific selected frequency. So I'm now really dealing with 100 hertz and very little either side. And when we get this, we call it a notch filter. So a nice wide Q will affect a lot of frequencies either side of your chosen frequency. And a narrow Q then starts to be useful for really surgical or precision frequency editing, where you can now sweep across your frequency band and you can find a resonance somewhere, typically in like a kick drum or snare drum, sometimes in your vocal performance. And you'll sweep through that frequency spectrum, find something that really jumps out, and that'll be your resonant frequency, and then you can pull it out, and you can do your cuts or your boosts as necessary. So another thing that is really important to have with your equalizer is, of course, your frequency spectrum analyzer. And this particular EQ has a spectrum analyzer, which is really cool. You can see from 20 hertz to 20 kilohertz is indicated over here. And as I boost, you can see on the left-hand side that it indicates the level by which I'm boosting or cutting. And all of this is customizable and scalable to suit your needs and your projects. So I just want to give you a really good idea of how this frequency analyzer works. So let me quickly switch this off and come into this EQ. So now when I play this instrument, you're going to see the frequencies mapped on this spectrum analyzer. Here we go. And you can see that there's quite a bit of low frequency content, lots of mid-range content, and even all the way up to around about 6 kilohertz. So what you can do now is you can put in your low-cut filter. And let's remove everything from around about 80 hertz or so. We don't need that. There's not a lot of content in there. And you can hear that it's not really making an audible difference to the sound, but it will give you a little bit of extra power and level available in your mix. In this area over here, you can see there's quite a strong fundamental frequency. So let's just manage that a bit. And I just want to increase the highs here a little bit, and then I'm going to use my high cut filter just to tidy up that top end and basically just focus on this area between around about 100 hertz and that cutoff around about 9 or 10 kilohertz, and just tame this area, and then we'll bypass. You can hear just a nice little subtle difference. And then, of course, the whole idea of EQ is you shouldn't be doing it in isolation if you've got a mix. But I just wanted to show you this spectrum analyzer. And I'm going to teach you a few tricks in EQ when you're mixing. So I'll catch you again in the next video.
Your